Okay, so hello everybody. Welcome to the talk on test-driven development effectiveness. My name is Krzysztof Jelski, and I'll start with introducing myself. I work for a company called Pragmatists. We're based in Warsaw, Poland. Here's a little site of Warsaw on the slide. And we're basically a software house. We do software for our clients, but also we do trainings. And I'm responsible for developing the training business at Pragmatists, and I also give trainings myself. And we, among other things, we do quite a lot of trainings on test-driven development, which somehow explains my interest in the topic we talk about today. Okay, so here's a little process that I'm sure at least some of you know. It's called test-driven development, and it basically goes like this. You add a test. You see the test failing because there's no functionality that the test expects. Then you add a little production code, you add the functionality, and see that your test is passing. And then you are safe to refactor. You can run all the tests you have done so far and check whether the tests still pass while refactoring. All right, so let's start with a simple study here in this group. So I'd like you to raise your hand if you do test-driven development, or your team does, or any team in your organization. So let's see how widespread TDD adoption is. Okay, I would say around 40% maybe of the group here. Okay, so I hope that my talk will give you some insights on why test-driven development might be worth adopting, and for those of you who already use it, it might also give some insights. So let's start with the anecdotal claims, so the things that I repeat on and on when I do my test-driven development training. So this is the stuff that I usually point to. These are the benefits I highlight when I introduce test-driven development. It's developer safety. So generally less stress. If you do test-driven development as a developer, you feel more safe. You you have less fear. Okay, so next thing, less defects. Certain classes of defects are eliminated by the use of test-driven development. It doesn't mean that we don't have to do manual testing. We still do, but still lots of defects go away. The next thing, better design. So if you do test-driven development, it pushes you towards better design, a design that is easier to maintain, and you forget how to use your debugger. If you forget the shortcuts, that's at least what happened for me. Anecdotal evidence, right? From the point of view of the managers, of the CEOs, there's one problem less to worry about. The problem, will it work on production? Well, it oftentimes goes away because the code was test-driven, so we know that it works. Of course, we need more practices to make it happen. We need continuous integration or continuous deployment, but it's the basis. It's the basis that we know that the functionalities created by developers work in the small scale. All right, so these are the claims that get repeated, that are usually backed up by stories like, well, it worked in company X, or my friends told me that their design got better after starting to use test-driven development. So let's try to look for some more hard data, some scientific data that would back up or maybe tell us that those claims are false. And why should we bother? What can we get from the scientific data? Well, we can get more evidence that we can use when we are proposing test-driven development, either to our team or to the managers. We can back up our claims with some scientific papers, scientific data. So we have proofs. Well, we can also get some insights. For example, if the studies show, well, there's no effect on this or that, or the effect is negative, and we still hear stories that it works well in some companies, well, but then maybe there are some other factors that are more important in certain contexts than test-driven development. For example, pair programming. Maybe for some variables it has more meaning than test-driven development. We can get such insights from scientific research as well. The other thing is that if we want to do scientific research, we need to have data. And to have data, we need to define metrics. We need to come up with ways how to measure different things. And even if we don't use the results themselves, maybe the way the researchers came to them may be useful for us. Because we could then use certain metrics ourselves in our context and use this data to make decisions. And if you want to collect lots of data on how developers work or how good the code is, you also need some tools. So it turns out that the researchers also create tools that help to measure interesting things. It's also a way we can benefit. Okay, so let me now go to the most interesting thing. To the most interesting stuff, I think. To what was research and what were the effects in the research I have found. So. What was already studied was how test-driven development affects those things, those variables. So the effects of test-driven development on internal quality were studied, effects on external quality, on test qualities, how good the tests are, does TDD change that or not? On developer productivity, and on project costs. So these are the things that I have found that have been researched. Now, among those things, there were things that no effect was observed on. So for example, in the studies I have found, no effect was observed on the test qualities. There are mixed results as to developer productivity. We'll come to that later. So some studies show that there is an effect, and some studies show that there is none. Okay, let's come back to that later. And not every result is statistically significant. So in fact, there are quite few studies that have good data as a background that you can draw statistically significant conclusions from. But at least some of them are. So we'll also look into that in a moment. But basically, that's the summary of the research. So there have been effects found on internal quality of the code or design quality of the code, how good the design is, on external quality. So which was usually operationalized as defects or defect density, and also there are some studies that show that productivity does not change, or that the productivity deteriorates, so gets worse. Okay, let's get into the details. But before I get into specific studies, I'd like to point out some common themes. Basically, most of the studies, or even most of the studies, follow the comparison between test-driven development and test-last development. So there are no studies that would compare test-driven development to a situation when you don't do unit testing or automated developer testing at all, or at least I haven't found such. There are different designs of the experiments performed. So sometimes there's the between subjects design, where you take your group, divide it randomly, whatever that means, into, let's say, 2 subgroups, and tell one group to do test-driven development and the other to do test-last, for example. Or in the industrial studies, there are also different ideas. For example, you take one team and take a team which is similar. Again, whatever that means. It's not very easy, right, to find 2 teams that are similar and can be compared, because there are a lot of variables, a lot of factors that have to be considered. There's also some studies that use the repeated measures design, where you take one group of people, ask them to do test-last development, treat it as a baseline, and then ask them to do test-driven development. The same people, different tasks, because otherwise it wouldn't make sense. So you have to find different tasks, but that can be compared to the previous ones, and you compare the results of whatever variable you're interested in. I think all the studies I have gone through do include test-driven development training at the beginning, and most of the studies are with subjects who haven't done test-driven development yet. And unfortunately, not all studies, but at least some, do measure conformance to test-driven development process. So to the process I have shown at one of the first slides. So it's also not very easy to do to assess whether someone is doing test-driven development or not. It's also an interesting subject in itself, how to do it. Okay, so let's go to internal quality. And there are some metrics that have been studied, and there are effects found on one of them. But I want to introduce the metrics first, so that you know what is it about. So we're in the context of object-oriented programming, object-oriented design. So all these metrics are related to quality of object-oriented code. Coupling between objects is basically how many invocations goes from a certain class to all the others. So how tightly is it coupled with other classes? Weighted methods per class is the sum of complexity of all methods in a class, and response for a class is the number of methods or constructors it calls. So the first study I'd like to share with you is by Lech Madejski. It was published in 2010. It was conducted sometime earlier. And it was done in academic setting. So students took part in this experiment. And there were more than 100 subjects, so quite a big study. And what the researchers found out was that there was medium and even close to large effect on the coupling between objects metrics. And I mean positive effect, so the coupling was in fact lower, okay? Because this is what we want. High quality code has low coupling. So the coupling was lower in test-driven development treatment and lower than in test last. So it does back up the claim that test-driven development leads to better design, because lower coupling is better design. And it, of course, somewhat makes sense why test-driven development does that, right? Because if we start with a test, then we have to, decompose our code so that it's testable, so that it's easy to instantiate a class, pass some dependencies to it, and so on. And this usually means that we'll create smaller classes components that are more loosely coupled to the rest of the system, so that we don't get too many dependencies in our test. So it does make sense. In the same research, the other two variables were studied, but no statistically significant result was found for those. Okay, so only one effect here, but statistically significant. Now, to give you an idea of how this research looks like, I want to go a bit deeper to show you what it involves, how it was constructed, and how it was conducted, this research. So let's go a bit into the details. So the research, in fact, is based on 3 experiments, and the data on the effect on statistical significance comes from a meta-analysis of those 3 experiments. And these are the name of the experiments. I put them on the slide to show you that researchers try very hard, even if they do the research in the academic world, to make it as close as possible to what we have in industry. So the subjects developed an accounting system, which was specified by someone from the industry, not from the academia. They have made a conference submissions application, and they also made a tool to detect code smells in Java code and some library to, I guess, convert HTML to XHTML, whatever. But you know, this stuff is kind of similar to what we do in a corporate environment. The researchers try to mimic that in their studies. And the research included 5 to 7 weeks preparation, depending on the experiment. It was done during studies of the subject, so it wasn't that they were working only on preparing for the experiment. They did it like 2 hours a week. So it's like 10 hours in total of the net preparation time for each subject. And they learned test-driven development. They learned the tools, JUnit, because it was in Java. So this was how it was prepared. And then let's say construction part was done. So there were user stories prepared for each experiment, between 23 to 27 user stories per each experiment, and the subjects did implement those user stories. Also, during the research, some custom tools were developed. So the researchers created an activity tracking tool to record what does the developer do with his or her IDE. So, where the test run, or what was the results of the test run, when was the code changed, and so on and so on. And by the way, they weren't able to judge from this activity data automatically whether the subjects did test-driven development or not. It still required some manual inspection. And they created a tool to measure those object-oriented metrics. And they also created a tool for mutation testing to measure effects on the quality of the tests. Okay, so that's for the details of how the study was conducted. We'll come back to it later. I'll show you the effects on productivity found in this study. But now let's go to external quality. So external quality was measured with the following metrics, like number of defects found, or the defect density. So how many defects do we have per thousands of lines of code? Well, there's also the idea that we can just measure the number or percentage of acceptance tests that passed, meaning that the researchers can create the acceptance test before the study and then run it on what the subjects will create. So it also gives an idea of the quality of the code, whether the requirements are met or not. In some studies also, the client was asked to give a quality mark for the effect of the work. Okay, so the most interesting data on external quality comes from a study by Rafik and others conducted in 2013. It was a meta-analysis of 27 research papers published on test-driven development, and it included both, the meta-analysis included both studies from the academic research and from industrial research. So the data showed that there is a effect, little but somehow significant, on the external quality, but only if we consider the industrial studies themselves. In the academic studies, there was no observable effect on external quality, which is also the case for the research by Madejski I have showed you. In that research, the percentage of acceptance tests passed was measured, and there was no effect on that metric. So there is effect on external quality coming from the meta-analysis, and let me show you two interesting studies that were included in this meta-analysis. One is by Slingshot from 2008. It was done in Statoil Hydro. I don't think there's such a company anymore, but it's kind of connected to Statoil. So industrial setting, more than 100 participants. And the result was, in this particular study, that the defect rate was lower by 1/3. Another interesting studies by Nagapen from 2008 in industrial setting, around 40 subjects. So this was an interesting experiment. It was performed at IBM and at Microsoft. So there were teams selected that took part in the experiment, working on some drivers for IBM and from Microsoft on Visual Studio, on Windows, on MSN. So kind of for normal product teams. And they were compared to other teams inside those companies that were somehow considered similar. So in this experiment, it turned out that the defect density for the teams doing test-driven development is much lower than for those that don't do TDD. So these are the effects, like 62% lower or even 90% lower in one case. Okay, so we have data that backs up the claim that test-driven development has a positive effect on external quality. What about productivity? So first, how do you measure productivity? I think it's a very brave task to measure developer productivity. I wouldn't dare, but the researchers do. And what they try to measure, what the metrics they define are, for example, development time per task or number of acceptance tests passed per hour, per unit of time. Okay. Well, in several studies, lines of code were used. I don't think it's a good idea, but still, some research uses that to judge on productivity. Lines of codes per amount of time, for example. So we have somewhat mixed data here, because the study I started with by Madejski from 2010 shows with statistical significance that there was no effect of test-driven development of number of acceptance tests passed per hour. So a productivity metric. So it was the same in test-driven development case and in case of test class development. On the other hand, the meta-analysis I have also referred to earlier shows that if we consider only industrial experiments, experiments performed in industrial setting, well, there is a decline in productivity. Well, I think it still needs some more investigation. It's hard to tell whether productivity is affected, how productivity is affected by test-driven development. But well, you may observe, yes, so referring to the data, you may observe that your productivity expressed as, I don't know, user stories completed per amount of time will drop during the test-driven development adoption. Okay, so these were the things that are backed up by research, and we have some statistically significant or at least otherwise compelling data to back up the claims. But let's also quickly go through the other things that were studied, but no effects were found. I think it's also interesting to go into that a bit. Because of, for example, the metrics, how do you measure different stuff? For example, how good the tests are. Does test-driven development affect how good your tests are. So the research was inconclusive here, but how did the researchers try to measure it? Well, one measure is code coverage, but you can argue it's not the best one. I think a very interesting measure is mutation score indicator. So who knows what mutation testing is? Mutation testing. Okay, few of you. So let me quickly explain it, how mutation testing works. So if you have production code, so there's a production code here, and here's an if statement, let's say, okay? An if statement, and if, I don't know, variable less than 0, then something, whatever. But we have an if statement. And we have a test suite. So this is our production code, and this is our test suite here. And the test suite, well, it should check both ways through that code, right? As in code coverage. But okay, so we have the test suite that should check this condition. And what we do in mutation testing is we take the production code, we create a mutant, and the mutant looks like this in this case. Oh, sorry. The mutant looks like this. If var, let's say, equal or bigger than 0, and the rest of the code is the same, okay? So the only difference is that it's changed, I know, in the bytecode, for example, if you take Java code. There is one change in the code, and you execute the tests against the mutant. So you have the test suite, which passes for the production code, and you execute the test suite against the mutant. And of course, it should fail, right? It should fail here. If it doesn't fail, it means that the test suite, well, isn't that good, because it didn't cover this case. Okay, so here the test passes, and here it should fail. If it doesn't, then well, it indicates a problem in our test suite. So if the tests fail here, it's called we killed the mutant. Okay, so the mutation score indicator is how many the percentage of mutants killed against the total number of mutants checked. Okay, so this is, I think, quite a bright idea of how to measure your test suite quality, and there are tools for that in Java, at least I know. So this is something you can try on your Java code. Okay, so one study also checked the number of negative test cases. So it goes like this: if we do test-driven development, do we do more or less test cases that are not like explicitly stated in the requirements, are for some different, some unusual inputs, for example, some exceptional inputs. Okay, so this was also an idea to how to measure whether the tests are good and are they affected by TDD. So the studies we have here, so the one I referred to by Lechmadejski, well, no effect observed on code coverage and no effect observed on mutation score indicator. And in a study from 2013 by Czałszewicz, also no effect on the number of negative test cases. So the same number of test cases was produced in test-driven fashion and in test-last fashion. Okay, so the last variable that has been studied was the cost, which was defined like fault cost. How much does it cost to fix a fault found in the code? Total project cost and maintenance cost. So the study is, there's one study on that topic by Dem and Landberg from 2006, and it's in industrial setting. Well, there are positive effects, so the costs got lower on test-driven development, but it's not a big effect and it's not statistically significant. So, you know, you can't draw to far-flung conclusions from that. Okay, so let's go to another topic. I mentioned that if you do such a study, it's worth knowing whether the subjects were really doing test-driven development or not. Okay, because it may not be enough if you train them and ask them to conform to the process, right? So how can you measure whether you do test-driven development? For example, in a study by Roberto Latore from 2013, this is the metric that was used. So you sum the number of test-driven development changes, which is creating a test and running a test before the production code. You sum it up with the number of refactorings and divide by all changes detected in the code. So that's one idea. How else can you answer the question whether you do test-driven development or a developer does test-driven development or not? Well, there's a tool in industrial logic learning. Hello, Josh. You can ask Joshua because it's their product on how that works. But well, it's a tool that kind of graphs what you do during your development time. So you see like compile errors, failing tests, passing tests, refactorings, stuff like that, right? So it kind of gives a sense whether it was test-driven development or not. Industrial Logic also created something called Test-Driven Development Dashboard, which shows the number of test-driven development cycles performed. And another tool I know of is something created by Michael Hilton and Danny Dick from Oregon State University. Well, it tries to visualize test-driven development process in a fancy way, so that you have each cycle depicted as something like this, 3 arcs of different width, depending on the time you have spent in each part of it. So what they have done is they are inferring whether test-driven development was performed or not only on the basis of the test run effects or refactoring number and so on, but they also using abstract syntax tree of the code to judge whether a certain change, what does a certain change mean. But the problem is, in fact, with all the tools, is that, well, you can't really, download a package, install a plugin into your IDE, and it will tell you whether you do test-driven development or not. So each of the tools has its drawbacks and limitations, and as far as I know, there's no such thing that you can just simply install and get data automatically whether you do test-driven development or not. So, here's something for developers to work on. For example, this work is open source, so you can use it and maybe create such a tool from that. So, okay, summing up, what can you do in your team? If you adopt test-driven development or already use it, it's worth to look at internal quality, external quality, and if you can, test-driven development conformance. If you find something that works here, let me know. It would be great. Well, you can do it you can do it manually, right? You can use, I know, pair programming to ensure that the conformance will be higher. So this is, from my experience, this works really well. If you have a team where all the production code is pair programmed, and the team agrees on using test-driven development, well, then pair programming helps to really really conform to that. But still, I don't know how to measure it automatically. Okay, so there is an effect of test-driven development on internal quality, positive effect. There is a positive effect on external quality. We have some mixed data on productivity. On the one hand, academic research shows with statistical significance that it doesn't matter whether we do TDD or test last. On the other hand, industrial studies show that performance is worse if we do test-driven development. So please take those conclusions as a rule of thumb, let's say, because it's something that can help us, but for sure it's not true in every context in the world, right? So we have to remember that context matters, that research has its own context, our teams may be different, so not everything can be simply applied to our context, but I hope I have given you some interesting insights and showed you some interesting data on test-driven development research. Thank you. Questions?
Thank you for the talk. I have some question, probably from real life, kind of. Suppose we have a repository interface, which is based on object relation mapper and which provides us Fluent API that allows us to build the queries. It's easy to mock, and we're writing unit tests on mocked implementation. We're getting them read, then we're writing the implementation of, for example, some business layers that is based on this repository. We are getting green unit tests, and it's all great. Unit tests are green, and then we're on staging or in production. We're using a real implementation of this repository with an object relation mapper, which cannot translate the query, for example, to a SQL.
Yeah.
And
okay.
We're getting and down production or staging and so on.
Yeah.
And my question is that actually we followed TDD, we wrote the tests, then wrote implementation and so on. Is this situation is a problem of TDD? And if it's so, then, for example, in our case, we're dealing with such cases. We're writing integrational tests that are using real implementation, and we're getting the feel of safety. Mm-hmm. Maybe you have, from your experience, other ways or other structured way of dealing with such situation and so on, or it's not a problem of TDD, and then you don't need to answer this question. Yeah.
Okay, so if I understand you correctly, you are asking if we have two layers, yes. One, let's say, database, one business layer, and we test the business layer with the mock of the database layer, then we can't really be safe to deploy, which is true. Okay, so test-driven development is, kind of a simple process. It does not prescribe very much. In particular, it doesn't tell you what kinds of tests should you write. Okay, so test-driven development, well, it doesn't say that you have to write only unit tests or tests with mocks, collaboration tests or whatever. So what the teams I know, what the teams do, is that they separately test the database layer itself, like with a real or in-memory database, and they check if the mapping is correct, if the queries are correct, and so on. And then in the business layer, mock is fine, right? Because you have you just have to have the same contract expressed here and there. So this is how I approach it. I understand it's the same what you do.
Yes, it's the same, but
that's
it's
fine. Yeah.
Basically, test-driven development is a situation when we're writing a test prior to the logic. But in that case, basically, we're getting a situation when the unit tests are working fine. We're written them before, but we are getting a situation when we should write the test after we get an issue.
Oh no! You also test drive the database access layer.
Okay.
Why not?
Okay.
You start with a failing test, then you add mapping, then you add create table, whatever you need, right? To make the test pass. You follow the same process. Okay? Any other question? Okay.
Thank you. Leave your feedback cards.
Thank you very much.